Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video, we will discuss about the MCQs on the topic torsion of shafts. So let us start. Question number 1. When a tangential force acts on the surface of the shaft is said to be in A. Bending, B. Buckling, C. Shear and D. Torsion. Whenever a tangential force acts on the surface of the shaft, it will get rotated and it is said to be in torsion. Hence, the correct answer is D. Torsion. Question number 2. The moment of a tangential force acting on the surface of the shaft about the center of the cross section of the shaft is known as A. Torque, B. Bending moment, C. Shear force and D. None of the above. When a tangential force acts, force into radius, that is the perpendicular distance, is the moment about the center of the cross section, which is known as a torque. Hence, the correct answer of this question is A. Torque. Question number 3. Due to twisting, following stresses are developed in the material of the shaft. A. Bending stresses, B. Tensile stresses, C. Shear stresses and D. Compressive stresses. Whenever a shaft rotates, every point in the material of the shaft will get twisted, and due to twisting, shear stresses are induced in it. Hence, the correct answer of this question is C. Shear stresses. Question number 4. The unit of angle of twist theta in a torsional equation is A. Degrees, B. Radians, C. Gradians and D. None of the above. Angle of twist theta in the equation of torsion, that is g theta upon L is equal to T upon IP is equal to tau upon R. Whenever you use theta in this equation, the unit of theta is always radians. Hence, the correct answer of this is B. Radians. Question number 5. When the shaft is in torsion, the shear stress at any point in the material of the shaft is directly proportional to A. Radius of the shaft, B. Distance of the point from the axis of shaft, C. Diameter of shaft and D. None of the above. Now friends, when the shear stresses are induced in the material of the shaft, the magnitude of shear stress depends upon the radial distance of that point from the center of rotation. As the radial distance goes on increasing, the stress will go on increasing, and at the center radial distance is 0, hence the shear stress will be 0. So in this question, this shear stress is directly proportional to the distance of the point from the axis of the shaft. Hence the correct answer is B. Distance of point from axis of the shaft. Question number 6. The ratio of polar moment of inertia to the radius of the shaft is known as A. Modulus of section, B. Polar modulus of section, C. Section modulus and D. None of the above. This is the definition of polar modulus of section, that is IP upon R, and hence the correct answer of this is B. Polar modulus of section. Question number 7. The polar modulus of section of the solid circular shaft of diameter D is A. Pi d raised to 4 upon 16, B. Pi d cube upon 32, C. Pi d cube upon 16 and D. Pi d raised to 4 upon 32. Now, in the previous question we saw that polar modulus of section is IP upon R. So, if you put the value of IP as pi d raised to 4 upon 32 and R as d by 2, you will get the value of polar modulus of section for solid shaft as pi d cube by 16. Hence, the correct answer of this is C. Pi d cube by 16. Question number 8. The polar modulus of section of hollow circular shaft of external diameter d and internal diameter d is A pi into bracket capital D raised to 4 minus small d raised to 4 upon 16d, B pi into bracket capital D cube minus small d cube upon 16d, C pi into bracket capital D cube minus small d cube divided by 16d, and D pi d raised to 4 minus small d raised to 4 upon 16d. Now this is exactly similar as the previous question, only here the shaft is hollow, therefore its IP will be pi into bracket capital D raised to 4 minus small d raised to 4 upon 32, and when you will put it the value of R and in the formula, you will get that expression as pi into bracket capital D raised to 4 minus small d raised to 4 bracket complete upon 16d. Hence, the correct answer of this is A pi into bracket capital D raised to 4 minus small d raised to 4 bracket complete upon 16d. Question number 9. The strength of the shaft is indicated by A. Its bending moment carrying capacity, B. Its capacity to resist shearing stresses, C. Its capacity to resist twisting moment or its twisting moment carrying capacity, and D. None of the above. When the shaft is in torsion, it is subjected to twisting moment, hence the strength is more when it can carry more twisting moment. Hence the correct answer of this question is C, its twisting moment carrying capacity. Question number 10. The strength of the shaft is directly proportional to polar modulus of section, diameter of the shaft, C both A and B, and D none of the above. Now the strength of the shaft is directly proportional to diameter as well as ZP, that is polar modulus of section. Hence the correct answer of this question is C both A and B. Question number 11. The torsional rigidity or torsional stiffness of the shaft is the product of modulus of rigidity G and Mi, B product of modulus of rigidity G and polar Mi, C the torque required to twist the shaft through unit angle, and D both B and C. Now for the formula, as far as the formula is concerned, the torsional rigidity is polar modulus of rigidity multiplied by polar Mi, and if you have to express it in word, it is the torque required to twist the shaft through unit angle. Hence both B and C is the correct answer. The correct answer is D both B and C. Question number 12. The stiffness of shaft is its torsional rigidity and dash 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 angle of twist. A directly proportional to, inversely proportional to, B inversely proportional to, directly proportional to, C directly proportional to, directly proportional to, and D inversely proportional to. Now here the stiffness is directly proportional to torsional rigidity and inversely proportional to angle of twist. Hence the correct answer is A directly proportional to, inversely proportional to. Question number 13. Which of the following is are assumptions made in theory of pure torsion? A. The material of shaft is homogeneous and isotropic. B. The shaft is straight having uniform cross section throughout. C. The cross section of the shaft which are plane and circular before twist remain plane and circular after twist, and D all the above. Now here if you see A, B and C, all are the assumptions made in theory of pure torsion. Hence the correct answer is D all the above. Question number 14. If the shaft rotates at a speed of n rpm due to an average torque of T Newton meter, the power transmitted by the shaft is given as 2 pi nt upon 16 horsepower, 2 pi nt upon 16 kilowatt, 2 pi nt upon 60 watt, and 2 pi nt upon 4500 watt. Now, if n is in rpm, average torque is in Newton meter, then the power which you get by this formula is in watt, and hence the correct answer is C, 2 pi nt upon 60 watts. Question number 15. For the same material, same length and same torque, a hollow shaft is dash 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 solid shaft. A. Heavier in weight than, B. Lighter in weight than, C. Equal in weight with, and D. None of the above. Now in this problem, comparison of hollow shaft and solid shaft is made. Now if same material is there, length of both shafts are also same, and torque applied is also same, then the hollow shaft which you require is of lesser weight than the solid shaft. Hence, the correct answer of this question is B, lighter in weight than. Thank you.